Hello everyone, welcome to my video lecture series on probability distributions, module 3 of 4th semester subject complex analysis, probability and statistical methods 18MAT41. In this video, I am going to explain random variables under which discrete and continuous random variables followed by problems. Module 3 probability distributions comprises of review of basic probability theory, random variables, discrete and continuous random variables, probability mass or probability density function. Under random variables, we are taking discrete random variables and continuous random variables. Under discrete random variables, we take two distributions, binomial distributions, Poisson distributions, and under continuous random variable, exponential distributions and normal distributions. Course outcome and course objectives. Course outcome. After completion of this module, students are able to apply discrete and continuous probability distributions in analyzing the probability models arising in engineering field. Course objectives. It helps the students to develop probability distribution of discrete, continuous random variables occurring in digital signal processing, design engineering and microwave engineering. Let me start with probability versus statistics. How these two differ with each other. Probability, that is the chance of an outcome in an experiment. That means chance of an outcome in a random experiment predicting the occurrence of future event. For example, while tossing a fair coin, outcomes are head and tail. So that means I can say probability deals with predicting the likelihood or occurrence of future events, whereas a statistic is the analysis of the frequency of past events. So let me elaborate this with an example. Suppose a drawer containing 50 socks, out of which 20 red, 10 blue and 20 black. Now the probability problem means what is the probability that we draw 2 blue or 2 red socks from the drawer, or what is the probability that we draw 10 socks all are black. Now coming to statistics, if we have no knowledge about the type of socks in the drawer, now we can have a question like this way. A random sampling of 10 socks from the drawer produces suppose 2 blue, 5 red and 3 black socks. What is the total population of red, blue or black socks in the drawer? So that means what? A probabilist starts by knowing the proportion of each and asks the probability of drawing red socks, blue socks from the drawer. But whereas statistician infers the proportion of socks by sampling from the drawer, correct? Or I can say in probability we are given a model and asked what kind of data we are likely to see, correct? Having a model and we can ask what kind of data we are likely to see. Whereas in statistics we are given data and asked what kind of model is likely to have generated with it. So with this we can just move on to now review of some basic probability theory. Now students, let us revise probability theory, the basic concept of probability theory. Suppose we take up some random experiment, then the total possible outcome of that random experiment is called sample space, denoted by S. A particular outcome, that is an element in S, is called a sample. For example, while tossing a coin, two possible outcomes are there, head and tail. So therefore I can say the sample space S is nothing but set consisting of H, T, and each head or tail is a sample in it. An event E is a subset of the sample space S. While throwing a die, we know that the sample space S consists of 6 elements, 1, 2, 3, 4, 5, 6 each face. Suppose if I say a event odd number, that is a subset of the sample space S, 1, 3, 5. Now what is probability? The probability is nothing but occurrence or happening of an event E. So if there are n exhaustive, That means it encompasses the entire range of possible outcomes. Mutually exclusive, disjoint, cannot occur the same time. So that means do not occur at the same time. And equally possible cases, that is have the same theoretical probability or likelihood of occurrence, which m are favorable to an event E. Out of n possible outcomes, m are favorable to that event E, then the probability P of the happening of E is given by P of E is equal to m by n. So that means I can say the probability of occurrence of an event E is nothing but ratio between the favorable to an event E to total possible outcome. Among total possible outcomes, how many are favorable to that event E. So probability is nothing but m by n. So the next point, the likelihood is always, the range is always between 0 to 1. The probability of an event E lies between 0 to 1. And we also know that the totality of probability, the sum of the probability of all possible outcomes should be equal to 1. So possible outcome, all possible outcome means it is a sample space. So I can say the probability of S equal to 1. So if I know the probability of happening of an event, say P, then probability of not happening of event is denoted by Q is 1 minus P. Since the total probability P plus Q is 1, then Q is equal to 1 minus P. Now let me take a concept, random variable. What is random variable? If every outcome of a random experiment, if we assign a real number, then it is called random variable. The process of assigning real number to every outcome of a random experiment. For example, if I take a random experiment tossing a coin, as all of you know that there are two possible outcomes, head and tail. For each, that means for head I am assigning a real number 0, and for tail assigning a real number 1. This is called a random variable. We usually denote by uppercase letters, say x. So x is equal to 0, 1. So that means assigning every element of a random experiment with the real number. The process is called random experiment. So I can say the random experiment, nothing but here I have taken x is equal to possible values to head, I have taken 0, and the tail is assigned with the number 1. Or I can say a real variable associated with every outcome of a random experiment is called random variable. Therefore, a random variable is a function or a mapping x from S to R. Every element in S is assigned with the unique element a real variable R, or it is usually denoted by uppercase letters x, y, z, etc. And it may be noted that different random variable may be associated with the same sample spaces. That means for same sample spaces we can define more than one random variable. For example, if I also, the set of all real numbers of random variable x is called range of x. So the range of x here is 0, 1. Now coming to this point, the different random variable may be associated with the same sample space S. For example, if I take up throwing a pair of dice, as all of you know that there are 36, 6 into 6, 36 possible outcomes. So for each outcome, we are assigning a real number defined by the random variable. So let me take one random variable of each outcome a comma b as maximum of a and b. So I have the range of this random variable x. Suppose if I define the random variable x as maximum of a comma b. So how I have defined now, student? X of a comma b is nothing but maximum of a comma b. So that means if I take each outcome, so 1 comma 1, the maximum among 1 comma 1 is 1. 1 comma 2, the maximum is 2. Likewise, say 2 comma 5, the maximum is 5. 6 comma 6, the maximum is 6. So that means the range can be here the random variable, if it is maximum of a comma b, then the range can be 1, 2, 3, 4, 5, 6. Now for the same sample space, if I take the another random variable, say y, so y of a comma b, if I take it as sum of a and b, so a plus b is y of a comma b. So then the random variable y takes the values, if I take one by one, so y of 1 comma 1. So what is y of 1 comma 1? According to the definition, y as defined as sum of a and b. A plus b is y of a comma b associated to each outcome, that is the sum. So that means y of 1 comma 1, if I take, it is 2. Y of 1 comma 2, that is 3. Y of 2 comma 4, that is 6. Y of 6 comma 5, 11. Y of 6 comma 6, 12. So what are the range now? Range, it starts with 2 to 12. So that means y is nothing but the range of y is here 2 comma 3 comma 4 comma up to 12. So that is what we have taken here. Different random variable can be taken for a sample space. Yes, for the given sample space, yes, we can take the different random variable. Now let me give one example. If I toss a coin twice, suppose a coin is tossed twice, so how many possible outcomes are there? That is 2 square, 4 possible outcomes, that is head head, head tail, tail tail and tail head. For each outcome, if I assign a random variable, say x as a count of heads, total number of heads turning, then what are the numbers, the real numbers it takes? Suppose the experiment is, we are taking tossing a coin twice, tossing a coin twice. So suppose a coin is tossed twice, let x be the number of heads in outcome, then each possible outcomes h comma h, the value of x is thereby it is 2, total number of heads. X of t comma h, the number is 1. X of h comma t, 1 head, so 1, and associated to tail tail, number of heads in that outcome is 0. So that's why the range of x is 0 comma 1 comma 2. Now the next is, now the random variable we can say as into two types of random variables. One is discrete random variable, another is continuous random variable. Now let me take the first discrete random variable. If a random variable x takes finite or countably infinite number of values, then x is called discrete random variable. And all of you know that the set of all real numbers of random variable x is called the range of x. So that means for a discrete random variable, the range of x is always finite. It is a discrete number or countably infinite number of values. For example, number of kids in a family, number of attempts to hit a target, number of heads in tossing a coin thrice, or number of stars in the sky, countably infinite number of values. Now what about continuous random variable, CRV? A continuous random variable, if a random variable x takes uncountable number of values, then x is called continuous random variable. That is, x can assume all real values within a given interval. So that means the range of x for CRV is in terms of an interval. For example, price of a commodity, age of a person, height of a person in centimeter, life of an electric component in hours. For all this, if you find the range, it will be in terms of an interval a less than or equal to x less than or equal to b. So this is an example. If it is a DRV, it takes point by point 2, 4, 6, 8, 10, etc. If it is a CRV, the range is now from this point to this point. Now if I want to draw a curve of a probability function for discrete random variable, the curve looks like this. For continuous random variable, the curve is a continuous function. Continuous function. It is a curve of a continuous function. So we take probability distribution for discrete random variable. So discrete probability distribution. So first we define probability function or probability mass function for a discrete random variable. if x is the discrete random variable taking values x1, x2, x3, etc. xn, that means the range of x is here, n values are there, and for each xi we find the values, that means the probability of x taking xi, that is probability of x equal to x1, probability of x equal to x2, etc., probability of x equal to xn, such that the first condition p of x is non-negative, greater than or equal to 0, and second, the summation of all the probability is equal to 1. Then p of x is called probability function for a discrete random variable x. That means the function p of x, I can say it is a probability function or probability mass function if at all it satisfies these two conditions. That is, for each xi, p of x must be non-negative, and second, the summation of all the probabilities must be equal to 1. Now, so we'll say the collection x and p of x. So that is called discrete probability distribution of x. Set of all x and p of x together is called discrete probability distribution of x. For example, if I toss a coin twice and let me define x, the discrete random variable, as number of heads, then we know that the sample space consists of 4 outcomes: head head, head tail, tail head, and tail tail. For each sample, so the value of x is now 2, 1, 1, 0. That means it is nothing but number of heads. So that means now we have outcome, the range is 0, 1, 2. For each, let me define its probability. So what is the probability of tail tail? 0 means tail tail. That is obviously 1 by 4. Out of 4, so one possibility is 1 by 4. Probability of x taking 1 means 1 head. So there are two possibilities, either ht or th. So that means 2 by 4. And probability of x equal to 2 means that is head head. So that is 1 by 4. So you can closely observe that is each is non-negative. The first condition holds, and if you sum it up, adding all these, it gives 1. So thereby I can say p of x is a probability function, and together this is called as discrete probability distribution for the random variable x as number of heads in two tosses of a coin. Next, to compute mean, variance, standard deviation and cumulative distributive function of discrete probability distribution. Mean, denoted by mu, is equal to summation x into p of x. Variance v is equal to summation x square into p of x minus mu square. Standard deviation sigma is equal to square root of v. If I want to find mean, variance and sigma, so for each x, the probability of x we have to calculate, then we have to use this formulas. Cumulative distributive function CDF, f of x equal to probability of x less than or equal to x. So that means we have to add all the probabilities till x. So that means f at x naught is equal to summation p of x less than or equal to x naught. So CDF is defined for all real values of x. Now next, expectation of h of x, E of h of x is nothing but summation h of x into p of x. Thereby the mean and variance I can write in terms of expectation. So mu summation x into p of x, therefore I can write it as expectation of x. Variance summation x square p of x minus mu, that is summation x p of x the whole square. So that means it is expectation of x square minus square of expectation of x. Next, continuous probability distribution. Now let me first define the probability density function or probability function for continuous probability distribution. As all of you know, for discrete probability distribution, the probability function p of x satisfies two conditions: p of x non-negative and summation of p of x must be equal to 1. Similarly here, probability density function of CRV, a real valued f of x, is called probability density function or PDF for CRV x if it satisfies these two conditions. That is, f of x is non-negative as like your discrete probability distribution, probability function p of x non-negative. But the second condition, there it is summation, here we have integral minus infinity to infinity f of x dx equal to 1. So for discrete probability function, it takes the discrete value so that we can take the summation. But here summation is nothing but we have to take integral since it is a continuous function. So if at all I want to say the function f of x is PDF, these two conditions must hold. That is non-negative and integral of f of x between minus infinity to infinity must be equal to 1. Now, if suppose a comma b is a subinterval of the range space of x, then the probability that x lies in this interval is defined to be the integral of f of x between a and b. That means probability of a less than or equal to x less than or equal to b, how we can find? That is integrating f of x between a to b. In case of discrete, it is just summation of probabilities. So here it is integrating f of x between a to b. For example, if you have f of x, this is the graph which we have taken. So it is a probability density function. Then integral from between a to b is nothing but probability of a less than or equal to x less than or equal to b. Next, similarly, we take mean, variance, standard deviation and CDF for continuous probability distribution. The thing is here, the summation is replaced by integration. Mean, mu is equal to integral x f of x between minus infinity to infinity. Variance, v is equal to integral minus infinity to infinity x square f of x dx minus mu square. Standard deviation, sigma is nothing but square root of v. Expectation of h of x for continuous probability distribution, e of h of x is nothing but integral minus infinity to infinity h of x into f of x dx. All we have replacing summation by integration. So next, what is the probability of a less than x less than b? Just now we have taken, it is integrating f of x between a to b. So which is nothing but f of b minus f of a. That means it is area under the curve f of x, which is a probability density function between a to b. Now what is CDF? How we can define? CDF f of x is nothing but, as all of you know, it is accumulating probability still x. But here summation is replaced by integral. So we have to integrate between minus infinity to till x. So integral of f of x between minus infinity to x. So therefore PDF f of x is nothing but derivative of CDF. So we can just take the derivative of CDF, which gives f of x back, that is the probability density function. Now let me take some problems. 1. A fair coin is tossed 3 times. Let x be the number of heads turned up. Find the distribution of x and also find mean, variance and standard deviation. So when we toss a coin 3 times, the total possible outcomes are 2 cube, 8 possible outcomes. So sample space S, we have these possible outcomes. Now for each outcome, we have to associate with the real variable, real number. So since x is the number of heads, so x is the number of heads turned up, so hence x of HHH is nothing but 3. HHT, HTH, THH, total number of heads are here 2. TTH, THT, HTT, so x, the associated number is 1, and TTT nothing but 0. So the same I have explained with the help of table. So for each sample or element of S, the associated x values are here. So that means what is the range of x? The range of x is 0, 1, 2, 3. Now for each x, we have to find the probability function p of x. So which I can find easily. So probability of x equal to 0, that means probability of no head showing up, TTT. So out of 8, 1 by 8. So what is the probability of x equal to 1? 1 head. There are 3 possibilities are there. So 3 by 8. X equal to 2, 2 head. HHT, HTH, THH. So it is 3 by 8. Probability of all 3 heads. So 1 by 8. So that means I can prepare a table for each x, that is 0, 1, 2, 3. Its corresponding probability function p of x is 1 by 8, 3 by 8, 3 by 8 and 1 by 8. So I can confirm it since this satisfies the condition number 1, non-negative. Each p of x is non-negative, and if you add all these things, so you will get 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, that is nothing but 8 by 8, that is 1. So that means this p of x is a probability function or probability mass function. So this collection together known as discrete probability distribution table. Now if I want to find mean, variance, standard deviation, So the formula for mean mu is equal to summation x into p of x. So just we take that sum of the product of x and p of x, 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8, which calculated upon we get 1.5. So the mean for this distribution table is 1.5. The variance formula summation x square p of x minus mu the square. So sum of square of this into product. So we have 0 square into 1 by 8 plus 1 square 1 into 3 by 8 plus 2 square 4 into 3 by 8 plus 3 square 9 into 1 by 8. Calculate this minus mu the whole square. Mu is already calculated, 1.5 the whole square. So if you simplify, so that gives 0.75. The variance of this distribution table is 0.75, or discrete probability distribution having the mean 1.5, variance 0.75, and standard deviation sigma is square root of this variance. So square root of 0.75 is 0.866. Problem number 2. A random variable x takes the values -3, -2, -1, 0, 1, 2, 3 such that probability of x equal to 0 is equal to probability of x less than 0, and probability of x equal to -3 equal to probability of x equal to -2 equal to probability of x equal to -1 equal to probability of x equal to 1 equal to x equal to 2 and equal to probability of x equal to 3. So that means probability of x having -3, -2, -1, 1, 2, 3, they are equal, and probability of x equal to 0 is equal to probability of all those x taking negative values. Now with using this data, find the probability distribution. So let me now assume the probabilities as p1, p2, p3, p4, p5, p6, p7. So the distribution table we have here. Now use the conditions given. The first condition by data p of x equal to 0 is probability of x less than 0. So that means p4 is equal to less than 0 means all these probabilities. So we have one condition, p4 is equal to p1 plus p2 plus p3. Now the second condition is probability of except x equal to 0 all are equal. So that means p1 is equal to p2 is equal to p3 is equal to p5 equal to p6 equal to p7. So these two datas are given in the problem. Apart from that, one property we have, since it is a probability function, sum of all this must be equal to 1. So that is, we have p1 plus p2 plus p3 plus p4 plus p5 plus p6 plus p7 equal to 1. So using this we can solve, since we have p4 is now p1, p2, p3 are equal. So p4 can be written as p1 plus p1 plus p1. So 3p1 plus P1, P2, P3, P5, P6, P7 are one and the same. So let me write in terms of P1 only. So that is now all are P1. So 6P1 plus this 3P1. So by substituting and simplifying we get 9P1, which is equal to 1, means P1 is 1 by 9. So the data which I have used here is P4 is P1 plus P1 plus P1, and this is nothing but 6 times p1. So totally it is 9 p1 equal to 1, means p1 equal to 1 by 9. So that means now I can get back p4. P4 is nothing but 3 times p1, that is 1 by 9. So p4 is 1 by 3, rest all is 1 by 9. So we have ready with the distribution table now. For corresponding to x, its probability function is 1 by 9, 1 by 9, 1 by 9. When x equal to 0, that is p4 is 1 by 3, 1 by 9, 1 by 9, 1 by 9. So if you want, you can recheck. All are non-negative, and if you add it once again, that is nothing but the reverse process. So the answer should be 1. Next, problem 3. The probability density function of a discrete random variable x is given below. It is given with the x varies from 0 to 6 and corresponding probability function in terms of unknown k. We need to find k, probability of x less than or equal to 5, probability of 2 less than or equal to x less than 5, expectation of x, and variance of x. First, to find k, since we know that this probability function satisfies two conditions. The first one is all these are non-negative. Second, sum of all these probabilities must be equal to 1. So summation of p of x equal to 1, using this condition, add all these probabilities, that is 49k equal to 1, means that gives k 1 by 49. So now I can find the probability of x less than or equal to 5. So that means adding all the probabilities up to 5. So it is 1, 3, 5, 9 plus 7, 16 plus 9, 25 plus 11, 36k. So k is 1 by 49. So the probability of x less than or equal to 5 is 36 by 49. Similarly, probability of 2 less than or equal to x less than 5. 2 less than or equal to x less than 5 means up to 4. So I have 5 plus 7 plus 9. So that is 21k. So which is nothing but 21 by 49. The next is expectation and variance. We have the formula expectation of x means mu, mean, that is nothing but summation x into p of x. So that is sum of the product of x and corresponding p of x, 0 into k plus 1 into 3k, 2 into 5k. So if I do that, it gives 203k. So which is nothing but 203 times 1 by 49, which simplifies to 29 by 7 or 4.1429. Then last one, variance, we have the formula that is summation x square p of x minus mu square. Mu is already calculated, that is 29 by 7. So summation x square p of x, that is nothing but 0 square into k plus 1 square into 3k plus 2 square 4 into 5k. So you have to add all those things, that gives 973k, which is nothing but 973 into 1 by 49 minus mu square 29 by 7 the whole square, which simplifies to 132 by 49, that is 2.6939. Next, a similar type of problem, a random variable x has the following probability distribution. So x and corresponding probability function, again some values are in terms of unknowns. So find k, then probability of minus 2 less than x less than 2, probability of minus 1 less than x less than or equal to 2, expectation and variance of x. First, as usual, summation of p of x equal to 1. So add all these probabilities, that gives a k plus 2k plus k, 4k plus 0.1 plus 0.2 plus 0.3, 0.6, 4k plus 0.6 equal to 1, or 4k is equal to 1 minus 0.6, that is 0.4. 4k equal to 0.4 means k equal to 0.1. So I can now go for substituting here. So the distribution table now takes, when x equal to minus 2 it is 0.1 already given, when x equal to minus 1 k, that means 0.1, when x is 0, 0.2, when x equal to 1, 2 times 0.1, that is 0.2, when x equal to 2, 0.3, when x equal to 3, it is 0.1. So we can now find the probabilities. Minus 2 less than x less than 2. So that means in between minus 2 and 2, excluding that. So that is probability of minus 1 plus 0 plus 1. These three probabilities. So adding, that gives 0.5. Now what about minus 1 less than x less than or equal to 2? So that means excluding minus 1 but including 2. That means it is 0, 1, 2. So adding this 0.2 plus 0.2 plus 0.3, that is 0.7. Now expectation and variance, we can use the formula for mu, that is summation x into p of x. So that gives, so I have minus 2 into 0.1 plus minus 1 into 0.1, we have written here 0 into 0.2, that is 0 plus 1 into 0.2, 0.2 plus 2 into 0.3, 0.6 plus 3 into 0.1, 0.3. Adding all, that gives 0.8. So variance or expectation, sorry, mean or expectation of x is 0.8, and variance, now we have summation x square p of x minus mu square. So summation x square p of x, I have the data written over here, that is squaring and multiplying with the probability function, summing of all the values. So I have 4 into 0.1, 0.4 plus minus 1 the whole square, that is 1 into 0.1, 0.1 likewise, minus mu the whole square. Mu is 0.8 already taken, so solving that gives 2.16. Problem number 5. A random variable x has the following probability function. X takes the value 0 to 7 and corresponding probability is given in terms of k here. Find k, probability of x less than 6, probability of 6 less than or equal to x, probability of 3 less than x less than or equal to 6, and find the minimum value of x, so that probability of x less than or equal to x greater than half. So first, to find k, once again we use that same condition, sum of the probabilities must be equal to 1. So if I add all these, we'll get 10k square plus 9k equal to 1, or which I can say it is 10k square plus 9k minus 1 equal to 0. A quadratic equation. So we can solve, the roots are here, obviously we'll get two roots. One is minus 1, another is 1 by 10, that is 0.1. So I cannot take k equal to -1 because the first condition says each must be non-negative. So but if I select k equal to -1, all this becomes negative. So among these two roots, -1 and 1/10, that is 0.1, we must select k equal to 0.1. So we can prepare the table by substituting the values of k, so which gives here. So when x equal to 0, it is 0. When x equal to 1, 0.1. When x equal to 2, it is 2 times 0.1. Simplify, all these numbers will get. So now I can go for computing all these probabilities. So probability of x less than 6 means up to 5, adding all the probabilities. So either you can do that probability of x less than 6, that is up to 5, or it is a complement of, we can go by another way, it is a complement of 1 minus probability of x greater than or equal to 6. Both way is correct, student. We can either take as it is x less than 6, or it is greater than or equal to 6 complement of this. So that means 1 minus probability of 6 and 7. We have to just take these two values. Complement of this is the probability of x less than 6. So which gives 0.81. Now the next problem is probability of 6 less than or equal to x. So that means probability of x greater than or equal to 6. 6 and 7 probabilities we have to add. 0.02 plus 0.17, 0.19. The fourth problem is probability between 3 and 6, excluding 3 but including 6. So 4, 5, 6. Add these three numbers, so it is 0.33. Now fifth one is slightly different question. Find the minimum value of x so that probability of x less than or equal to x exceeds half. So what x, the minimum x, so that the probability exceeds half. If I closely observe, up to this it is 0.5, half. See, 0.1 plus 0.2 plus 0.2 up to x equal to 3. So that is x up to 3, it is 0.5. So if it exceeds 3, that is up 4, 5, 6, 7, all that gives more than half. That means the minimum value of x must be equal to 4. So I can say probability of x less than or equal to 3 is 0.5. So the minimum value of x, probability of x less than or equal to x exceed half is minimum x must be equal to 4. So for 4, 5, 6, 7, of course, probability of x less than or equal to x is greater than half. But I want the minimum value of x. So that is x equal to 4. Question number 6. Suppose a random variable x takes the values -3, -1, 2 and 5 with respective probabilities are given again in terms of k. Find k and these two probabilities, that is -3 less than x less than 4 and x less than or equal to 2. Similar type. So we know that summation of p of x must be equal to 1. Add all these probabilities. So that gives 5k minus 5 by 10 must be equal to 1. Simplify this, k equal to 3. Now I can prepare a table for corresponding to -3, -1, 2, 5. The probabilities are here. 2k minus 3 by 10. Substitute k values in each. So we'll get 0.3, 0.1, 0.2, 0.4. We can just substitute the values of k, students, here. So which simplifies to this. Now if you want, you can recheck. The sum should be equal to 1. Now we can go for number 2, number 3. That is probability of -3 less than x less than 4 means here excluding -3 and so 4 is not there. So that means in between these two, that is -1 and 2, probability of -1 plus probability of 2, that is 0.3. Probability of x less than or equal to 2. So that means here actually x less than or equal to 2, two way we can go. Either you can add up to this, or it is the complement of x greater than or equal to 2. But greater than or equal to 2, available value is only 1, 5. So that is 1 minus probability of 5, that is 1 minus 0.4. Both way we get the same answer, that is 0.6. Next, problem number 7. A random variable x has density function f of x equal to kx square defined in an interval 0 less than or equal to x less than or equal to 3, 0 elsewhere. Evaluate k and find the probabilities x less than or equal to 1, 1 less than or equal to x less than or equal to 2, x less than or equal to 3, x greater than 1 and x greater than 2. Now if I observe this probability function, this is defined in an interval 0 less than or equal to x less than or equal to 3. The range is in terms of an interval, that means this is related to a continuous random variable x. The random variable is a continuous. So we know that the probability density function for continuous random variable satisfies the condition, that is, first is non-negative, the second, the integral of f of x between minus infinity to infinity must be equal to 1. And also the probabilities we have to find integrating the probability function between the defined interval. As all of you know that probability of a less than or equal to x less than or equal to b. So what is that? So it is nothing but integrating f of x. We know that the probability for an subinterval a less than or equal to x less than or equal to b, we can find by integrating the given probability function between these values between a and b. So problem 2.1.2.5, we have to integrate the probability function once we find the value of k. So we can go for it. As all of you know now, condition for probability density function is nothing but the second condition I can use, that is integral of f of x between minus infinity to infinity must be equal to 1. So we can go for it. Since integral f of x dx between minus infinity to infinity is 1. So function here f of x is defined in the interval 0 to 3, it is kx square, elsewhere it is 0. So that means this we have to take minus infinity to 0 plus 0 to 3 plus 3 onwards, 3 to infinity. So that means in the interval minus infinity to 0 it is 0, 0 to 3 it is kx square, and 3 to infinity once again it is 0. So we have to restrict to interval 0 to 3. So integrate kx square, x square integral is x cube by 3, kx cube by 3, apply the limit, upper limit, that is 3 cube 27 by 3, 9k minus lower limit anyhow 0, it vanishes. So 9k equal to 1 means k equal to 1 by 9. So thereby I can say the PDF is nothing but 1 by 9 times x square, or x square by 9 in the interval 0 to 3, elsewhere it is 0. So let me now take probability of x less than or equal to 1, which is nothing but minus infinity to 1. The range for x is now up to 1 from minus infinity. So the probability is nothing but integrating f of x from minus infinity to 1. But it is defined only in this interval 0 to 3. So that means minus infinity to 0, the function is 0, plus 0 to 1. 0 to 1 is a subinterval of this. So thereby I can say in the interval 0 to 1 also it is x square by 9. So just integrate x square by 9 in the interval 0 to 1. Integral of x square is x cube by 3. Outside I have 1 by 9. So x cube by 27. Upper limit 1 minus lower limit 0. 1 minus 0. 1 by 27. So the probability x less than or equal to 1 for this probability density function is 1 by 27. Now what about probability of 1 less than or equal to x less than or equal to 2? That is again in the same line. So that means we have to integrate f of x between 1 to 2. So 1 to 2 is the subinterval of this 0 to 3. So that means it is again defined in that interval also x square by 9. Integral of x square by 9 is already taken, x cube by 27. Apply the limits. So I have directly taken that. So actually it is integral from 1 to 2 x square by 9. Integral of x square by 9 is x cube by 27. Upper limit 2 minus 2 cube minus 1 cube, 8 minus 1, 7 by 27. So what about probability of x less than or equal to 3? That means we have to integrate from minus infinity to 3. Minus infinity to 3. But minus infinity to 0, anyhow it is 0. So 0 to 3. But 0 to 3 means the full interval. So obviously we should get 1. So it gives the total area under the curve. So what is the function here? X square by 9. Integral of x square by 9 is x cube by 27. Upper limit 3 cube 27 minus lower limit 0, 27 minus 0, 27 by 27. As expected, the answer is 1. Now probability of x greater than 1 means 1 onwards. So the limit is now 1 to infinity. Integrate f of x between 1 to infinity means 1 to 3. Up to 3 it is x square by 9. 3 onwards, 3 to infinity, once again it is 0. That means again it restricts to 1 to 3. So x square by 9 integral is x cube by 27, but apply the limit 1 to 3, upper limit minus lower limit, that is 27 minus 1, 26 by 27. The last one is probability of x greater than 2, that is nothing but now x cube by 27. So it is 2 to infinity. So I have to apply only 2 to 3. 3 onwards again the function is 0. So 3 cube 27 minus 2 cube 8. 27 minus 8 19. 19 by 27 is the answer. Problem number 8. Suppose that the error in the reaction for a controlled laboratory experiment is a continuous random variable having the PDF. The PDF is defined f of x equal to x square by 3 in the interval minus 1 less than or equal to x less than or equal to 2, 0 elsewhere. Find the cumulative distributive function f of x and use this CDF to evaluate the probability between 0 less than x less than or equal to 1. Now to find CDF, we have to find CDF for all values of x. Now x we have here in the interval minus 1 to 2, it is defined as x square by 3. Elsewhere it is 0. So that means if I want to find the CD of f of x for x less than minus 1, what is the CDF? Obviously the CDF is 0. Why? Because as you know, if x less than minus 1, f of x, the CDF means what? The CDF f of x actually is nothing but cumulative probability. We have to integrate, instead of summing, we have to integrate f of x dx. But what is the range now? Range is f of x means what? From minus infinity, we have to start from minus infinity till x. Actually that is the meaning of CDF. But this x is less than minus 1. It is less than minus 1. Mean maximum it can be up to minus 1. But x can be any value. But x is less than minus 1. But whatever the value, elsewhere it is 0. PDF is defined as 0. So that means the integrand is 0, means obviously the CDF is 0. Now what about the second? If I want to take now between the range minus 1 to 2, if I take x any value between minus 1 to 2, so how it will be? If minus 1 less than or equal to x less than 2, then f of x is obviously, again as I told, it is integral of f of x from minus infinity to x. But x can be anywhere between minus 1 to 2. So minus infinity to minus 1, the function is 0. That means it starts from minus 1 to any x. So integral minus 1 to x. But minus 1 to x is the subinterval of this interval minus 1 to 2, where f of x is x square by 3. So integrate this x cube by 3, that is x cube by 9. Upper limit is x, lower limit is minus 1. So upper minus lower. So x cube minus of minus 1 the whole cube means x cube plus 1 by 9. So the CDF is now x cube plus 1 by 9. What about now for x greater than 2? So all possibilities you have to take. For x greater than 2, then the probability, sorry, the CDF cumulative distributive function must be equal to 1. That means it covers the entire PDF, correct? So x is greater than 2 means minus infinity to x, where x can be any value more than 2, correct? So that means minus infinity to 0, it is anyhow 0. But minus 1 to 2, it completely takes full range, that is x square by 3 plus 2 onwards, 2 to any value, again it is 0. But this answer is 1. So finally I have CDF for x greater than or equal to 2 is 1. So that means I can write the probability, sorry, cumulative distributive function as 0 for x less than minus 1, x cube plus 1 by 9 for minus 1 less than or equal to x less than or equal to 2, and 1 for x greater than 2 or 2 less than x. Now by using this, can I find the p of 0 less than x less than or equal to 1? Just observe student, if I want to find the probability function by the help of CDF, how we can find? PDF all of you know, that means we have to integrate between 0 to 1. F of x already known to us, by this I can find, that is integrating between 0 to 1, that is using PDF. Okay, now that actually what it gives now, this gives, suppose I don't know what curve it is, some curve, whatever the curve we have, so area under the curve between 0 to 1. Now if I take up to 1, area up to 1 means from minus infinity up to 1, that is nothing but f of 1. Total area up to 1 minus total area up to 0 means f of 0. That gives cumulative, actually cumulative. So that gives the required area what we are about to find. So that means f of 1 minus f of 0 gives the area between 0 to 1. So by cumulative distributive function also we can find the probability for a given interval, that is f of b minus f of a. Standard formula we can use. So or else I have just explained it. So that means now one can go for finding probability of 0 less than x less than or equal to 1 by using the CDF which we just obtained. So which is nothing but f of 1 minus f of 0. F of 1 is nothing but, now 1 comes in this range, so that is x cube plus 1 by 9 means 1 plus 1 2 by 9, minus f of 0, that also in this interval minus 1 to 2. The function CDF is defined as x cube plus 1, just substitute x equal to 0, that is 1 by 9. So 2 by 9 minus 1 by 9 is 1 by 9. If at all you use the PDF also, you will get the same, since it is integrating x square by 3 in the interval 0 to 1. Integral of x square is x cube by 3. X cube by 3 into 3. X cube by 9. Upper limit is 1 minus lower limit 0. So it gives 1 by 9. By PDF also we will get the same answer. Number 9. The troubleshooting of an IC is a random variable x whose cumulative distribution function is given by f of x equal to 0 for x less than or equal to 3, 1 minus 9 by x square for x greater than 3. If x denotes the number of years, find the probability that the IC will work properly. A less than 8 years, B beyond 8 years, C from 5 to 7 years, D from 2 to 5 years. That means by using the CDF, we need to find the probabilities. Correct? The first one, P of x less than 8. So what is probability of x less than 8 means, actually it is integral of f of x, a PDF. If I take a PDF, f of x between minus infinity to 8, that is the meaning of probability of x less than 8. Correct? So which is nothing but, obviously here we are summing up all the probabilities from minus infinity to 8, means that is the cumulative distributive function. So f of 8. So that's why we have written p of x less than 8 is nothing but f of 8. I hope it is clear. Now what is f of x, how it is defined? If at all that is lies between 3 onwards, 3 to infinity, the function is 1 minus 9 by x square. So clearly 8 here in this interval, so f of 8 is 1 minus 9 by 64, that gives 55 by 64. Now what about beyond 8 years, student? That is probability of x greater than or equal to 8. So that means it is a complement of 1 minus probability of x less than 8. That is 1 minus f of 8, which we have already calculated. So 1 minus 55 by 64 gives 9 by 64. Problem number C, that is probability of 5 less than or equal to x less than or equal to 7. So that means in terms of CDF, it is f of b minus f of a, f of 7 minus f of 5. Just now we have seen in the last slide. So what is f of 7? So that is x greater than 3. It comes in this. So it is 1 minus 9 by 49 minus f of 5. That is 1 minus 9 by 25. Simplify this, we'll get 216 by 1225, that is 0.1763. Problem number D, here the sub question is from 2 to 5 years. Once again same way, f of 5 minus f of 2, which simplifies to f of 5 is 1 minus 9 by 25, because x is greater than 3. And what about f of 2 now? It is comes in this interval, x is less than or equal to 3, then the probability, cumulative distributive function CDF is 0. So that's why f of 2 is 0. So which simplifies to 16 by 25 or 0.64. In this video we have taken discrete random variable and continuous random variable. So in coming videos we are going to take the distribution for discrete as well as continuous random variables. Thank you.